Hi guys. So today we are going to continue the tutorial. This time this is the tutorial number 1, which is the second tutorial. This time I'm going to explain more about the statistical test behind what I've shown in the last week, which was what's happening in the program in the background, what is the actual statistical test. But before we are going to do that, we are going to talk about biology a bit. So in the human, we have in humans we have 24 types of chromosomes. There are 1 to 22, and then we have X and Y. Right? It's a very common knowledge, nothing very new in here. Each chromosome is a compact structure that have a lot of DNA in it. And this DNA is basically consistent of 4 types of nucleotides, which is A, T, C, G. And when we are looking in file types, for example, bed files, we have the main, we have 4 columns. The first column is which chromosome it came from. The second is the index from the start of the chromosome until the end. The index where we're starting to look at this specific sequence. And the third one is where we're stopping to look at this sequence. And the third is the actual sequence itself, which is a string consistent of those letters. Okay? So I'm interested in specific letters which called CPG. In those specific cases, I'm interested in something that's called DNA methylation, which is a chemical modification. If you're interested in more details about my research or about this specific subject or any subject that came up, just let me know. I can do biology tutorials. But today we are not going to focus on it. We are going to focus on the statistical tests. So, in the last video, I showed you that I'm taking for the background file all the CPG sites in Illumina, which means that I'm letting the program know that this is the world I'm working with, okay? So after I'm giving the program the background file, I'm giving it 2 target files, which is a specific groups of CPG sites that I'm interested in. They are my region of interest, okay? And I want to ask if target 1 and target 2 have an overlap that is significant or not, or they don't have an overlap and this is significant. But I don't know if the overlap is randomly or not. So what I'm going to do is to take the background file and create from it 2 random groups, one in the size of target 1 and the 2 is in the size of target 2, and then I'm going to do an overlap, and in this overlap I'm going to basically do this experiment thousands of times, and then I'm going to get a distribution. The distribution basically shows me what happens in the null hypothesis. What happens if the 2 targets are, as far as I know, do not have any kind of dependence on each other. And then I'm coming back to my targets, original ones, and I say I have some value, specific value of overlap, and I want to see where it is happening compared to my null hypothesis distribution. And then I basically test if it's very far away or close. If it's far away, it's significant, the p-value is low, and if it's close, the p-value is high. And I also test two-sided or for enrichment and depletion. If you know already that you are looking for depletion, or if you know already that you are looking for enrichment, you can take those specific values and not the whole, not the two-sided, which is harsher. So in this case, we can see that I got depletion. Why? Because I get it from the left side. If I were getting it from the right side, I would get an enrichment. So that's it, and thank you very much.